Okay, so in this video we're going to be going through how to do these sorts of questions where it's involving the scale factors but with volume. If you haven't watched the area one, make sure you watch that first, just because it's sort of the same idea, just there's one little tiny bit that's different. So we're going to go through EG1. Now I've made this even simpler just so that you sort of understand the reasoning why we do what we're going to be doing. Otherwise it sort of won't really make sense, but hopefully this explanation will. So you'll be given two 3D shapes. Later on we are going to do some wordy ones, so we'll come back to that. Just that you know, you are going to need a calculator at some point, so make sure you've got one of those. Okay, so for EG1 we've got these two shapes. Okay, they're cuboids, one called A and one called B. Now normally you wouldn't get all three measurements or dimensions on the side, but just to help with understanding, as I've said, I've written those on. Now we're told that the volume of this one is 24 in the question here, okay, and we need to find the volume of the larger one. So the first thing you need to do is find out the length scale factor. So this part here of our cuboid is the same as this part here of the larger cuboid. Okay, so we can work out the length scale factor with these two. So the length scale factor is going to be the larger one, so 6 divided by the smaller one, which is 3. So 6 divided by 3, which is 2. Okay, most of you can work out that 3 times 2 gives you 6, so if you can do it visually, then brilliant. If you can't, that's obviously the method. Okay, so then if we do the rest of them, so this base, the base of A is 2, so we need to multiply that by 2, and that'll give us 4. Okay, and same for the height one, that needs to be multiplied by 2 as well, which gives us 8 centimetres. Okay, now to find the volume, what we do is we multiply all of them together. So I'm going to do this in blue. So volume of B would be the 8 times the 4 times the 6. 8 times 4 times 6. Okay. 8 times 4 times 6 equals 192 centimetres cubed. Okay, so we've worked out the answer. Now, a quick way. If we look at the volume of A and the volume of B, if we see how many of those go into here, so 192 divided by 24, and that gives us 8. Okay, so this is telling me that the volume scale factor is equal to 8. Okay, now if we look at, we know the length scale factor is 2, so that means actually 8 is the same as 2 cubed. So if we just cube the length scale factor, we would always get the volume scale factor. Okay, so volume scale factor is the length scale factor cubed. Okay, so that's really important that you write that down, and it is something you need to learn off by heart. Okay, so we're going to be using that the whole way through to help us. The reason why it's cubed is because if we look at this example again, each of those sides has been multiplied by the scale factor, so for this question multiplied by 2, which means that actually the volume scale factor has multiplied by 2 to the power of 3 because all 3 sides have been enlarged by the scale factor. Okay, now you don't need to know that. If you just want to remember the rule, that's absolutely fine, that's your decision. Okay, so I'm just going to move it up a little bit. You'll still see the formula. Okay, so they generally do more complicated shapes, even though actually the method is no harder. So we've got 2 cones, okay, X and Y. We're told that the bases are 10 and 30. The volume of X is 150 centimetres, so we know the volume of that one. We need to find the volume of Y. So again, the first thing we do is find the length scale factor, and we do that by using these numbers on the bottom. So what do we need to multiply 10 by to get to 30? Okay, or you can do the division way, so 30 divided by 10, which gives us 3. Okay, so to work out then the volume scale factor, okay, we just do the length scale factor cubed. Okay, that's what the formula says here. Okay, which gives us 27. So to find the volume of the larger one, if we know that the volume of this one is 150 centimeters cubed, we just need to multiply it by the volume scale factor, so multiply by 27. Okay, so 150 multiplied by 27, 4,050 centimeters cubed. Okay, and that's the final answer for that question. So they're not too far different to when we did the area ones. Okay, so EG3. Okay, a little bit harder because there's just words. I'm going to try and attempt to draw a pyramid. I'm not sure why, but I am. So it doesn't specify what type of pyramid, so I'm just going to draw a dodgy square base, triangle base, whatever one. There we go, that'll do. Okay, I'm just going to call them A and B. Not that it really makes a difference, it sort of just helps me. So we're told the volume has 32, so the volume is 32 centimeters cubed. Okay, the vertical height, so that is the height from the point right at the top down to the middle of the pyramid. Okay, so I'm just going to draw a little arrow here to represent that, and that's 8 centimeters. Okay, then a similar pyramid has a volume of this, so a volume of 16384 centimeters cubed. Okay, and we need to work out the vertical height. Okay, so that is what all of that is saying. So we're going to start off with, we need to work out what the volume scale factor is, okay? And we're told what both the volumes are, so that's going to help us out. So, volume scale factor. Okay, so we're always going to do the larger one divided by the smaller one. So 16,384 divided by 32. Now you will be getting quite big numbers, so I would always say use a calculator. Divided by 32, which is 512. Okay, so volume scale factor is that. Now, vertical height, these are just lengths, so we actually do need to find the length scale factor. So, length scale factor. So, as I said before, I'm just going to scroll down a moment with this formula. So, the volume scale factor is the length 1 cubed. So, to get from the volume to the length, it's going to be the cube root. So this button here, on my calculator it's this one, but you've got to click shift first. I think it's the same on these ones as well. Yes, it is. So you click shift and then the square root button, which is there. Okay, so let me just scroll back up. So the length scale factor is going to be the cube root, so with a little 3 there, of 120. So shift, square root button, if you can see you've got a little 3, and then 512, which gives us 8. Okay, so if you want to know that, the formula, so the length scale factor is the same as the cube root of the volume scale factor. Now you don't need to remember that off by heart if you just remember the original one, and then just know how to get back and forth from both. So we know that the length scale factor is 8. We know that the vertical one of the smaller one is 8 as well. So what we do is we just multiply the vertical height with the scale factor of 8. So 8 times by 8, which gives us 64 centimetres. So that is our final answer there. Okay. Okay, last one. Very wordy, sorry. Okay, if you're someone that struggles with words, I would be honest, I'm not particularly the best with words. Use a highlighter, so I'm just going to go through the bits that are important. So name Vicky isn't too important. It is important that they're both similar, okay, because that means that we can use the rules that we've been using. Okay, we're told the diagrams, which is really important. We are told that the larger one has this volume of 1,620, okay, and we're also told that the smaller one has a volume of 60, okay, so it's going to be quite similar to the one above. We need to find the dimensions of the smaller. So dimensions just mean the lengths on all the sides, okay? And that's why we're given all the lengths here. So to be able to convert lengths, we need the length scale factor, okay? We can't work out what the scale factor is at the moment because we're not given anything on the smaller cuboid, okay? But we are given the volumes of both. So we can work out the volume scale factor to start off with. So volume scale factor. Again, largest volume, which is 1,620, divided by the smaller volume, which is 60. Now, I'm not going to include any units at the moment. I'll deal with those at the end. So 1,620 divided by 60, and we get 27. Okay, so the volume scale factor is that. We need to find the length scale factor. So to do that, we need to find the cube root of 27. Now, if you can do it in your head, brilliant. You should know what it is, but if not sure, shift square root 27 equals, and you get the answer of 3. Okay, so we're told the length scale factor is 3. So to work out the dimensions of the smaller cuboid, all we do is divide all of these by 3. Okay, so this one here is going to be 15 divided by 3, which is 5 inches. Okay, this one here is going to be 12 divided by 3, which is 4 inches. Okay, and the last one, which is the height, which is going to do 9 divided by 3, which is 3 inches. Okay, and that's how you do these sorts of questions.